Well, I'm back. Part 2. I got interrupted, so I had to stop the video and start a new one. So here we are, back to where we left off. We had just graphed the inverse of the exponential function 2 to the x power. So we graphed this one, and so now you know what a logarithmic function looks like. So this one, remember, is our exponential function. Okay, and then this is what a logarithmic function looks like. So also notice it has a vertical asymptote. Whereas the exponential function has the horizontal asymptote. Okay? Also notice that the line of symmetry is y equals x. And so if I drew in y equals x, notice how it splits it into two pieces. Y equals x. So this flips over y equals x. So if you flip a graph over y equals x, you get its inverse. That's their line of symmetry. Okay, some of us are struggling with domain and range. There's a couple people that are doing end behavior here, and I'm not sure why. You know who you are. Domain and range. So doing the domain for our exponential function, we're going to the left infinitely. Okay? And we're going to the right infinitely, because we see arrows on the ends. We're going infinitely to the left and infinitely to the right. And whenever you are going infinitely in both directions, you can also use the symbol for all real numbers. X is an element of all real numbers. Okay? Range, since we have an asymptote here, you know that this graph doesn't cross this asymptote. So the graph is approaching 0 on the low end. And then on the high end, it's going to infinity. And since it doesn't ever get to 0, we're going to use a parentheses. Logarithmic domain. Okay, so notice going to the left, we're hitting a vertical asymptote. So the domain for the inverse is just going to be the range of the exponential. So the domain of the logarithmic is the range of the exponential. They're inverses, remember? We switch the x and the y, so the y, range is your y, that becomes your x. So very simply, 0 to infinity, 0 on the left, infinity on the right. Okay? The range is going to become the domain. So the range, it's going down infinitely, and it's going up infinitely. Okay, moving on to example number 2. Here we're given a logarithmic function. Okay, we're expected to make a table, and then we're going to find the inverse of that function, the equation. Let me get my calculator for a moment. Okay, so the first thing we're going to do here is I'm going to show you how to change from logarithmic to exponential. It's very simple. Remember that the number down here, the little number, is the base. This is called the argument. Okay, so the base is going to be our base of our exponential function, and then the argument here is going to be the exponents following this rule that we looked at above. See the b, the base, okay, and then the argument. So this is going to be 3 to the x power. That is going to be your inverse function. Remember, we are calculating, we are determining the inverse when we're doing this. Okay? So our calculators can help us out here. This is very simple. We could do that in our head, but I want to show you, hopefully your calculator has a new operating system. But if you'll go to y equals and then press math, number, actually stay on math, and we're going to go down to log base, which is letter A. We press enter. Okay, and we know that our base is 3 and our argument is x. So once we plug that in, we can go to our table, okay, and we can go ahead and plug in some of these numbers. So we know we have a point at 1, 0, 3, 1. See any other good points? 9, 2. So there's some nice points. And then very simply, to get your inverse points, we can just switch them. And then we can graph them. So let's graph our logarithmic function first. So 1, 0, 3, 1, 9, 2. Okay, so recall that we have a vertical asymptote right here on the y-axis. So we have a vertical asymptote right here. So our line's going to go along that asymptote and it's going to curve over. This is logarithmic. That is logarithmic. Now this vertical asymptote is associated with h, whereas this horizontal asymptote is associated with k. But we'll look at that a little bit later. For inverses, everything is the opposite. And then graphing our exponential function, we have 0, 1, 1, 3, and 2, 9. So again, we need to know the basic idea here. We go along that horizontal asymptote through our special point and up. And then we have our horizontal asymptote for that one. And of course, we have our line of symmetry for showing inverses. Y equals x. Exponential, logarithmic. Now don't get this confused with square root, because the square root starts at 0, 0 for a parent and goes up and over. Notice this one goes down along a vertical asymptote. Okay, so go ahead and do the domain and range for this problem. And in class, we'll take a look at some of these in class tomorrow. Have a good night. We'll see you guys tomorrow.